Hey guys, thanks for watching. Today's video is kind of the last piece to this section of the chapter. If you notice the title, we're looking at the difference of two random variables, whereas in the past we've been only looking at the sum of two random variables. So we're looking at Pete plus Erin. So by the end of the video, you should be able to make an educated guess. I feel like most of you will be able to figure it out about how we calculate the mean and the standard deviation of the difference between two. So difference is a subtraction problem. That is like Pete minus Erin. So because Pete has one more spot in his Jeeps, Pete and Erin's dad want to know how much better Pete's business does compared to Erin's business. So we're going to be looking at Pete minus Erin instead of the other way around. So you're going to have to be very careful about which way you're subtracting, because obviously if we switched it, we would get very different numbers in our distribution. So I want you to think about how large or small the distribution is going to become, because we're subtracting every single value from Pete's random variable by every single value in Erin's random variable. So if you think about that, it could be Pete has 4 and Erin has 4. So 4 minus 4, we get 0. Or maybe Pete has 6 and Erin only has 2. Still, we've never seen negatives before. So what if Pete only has 2 and Erin has 5? Now 2 minus 5 is a negative 3. But that's okay. A negative number is just going to mean that in that particular day, Erin had more people on her Jeep tour than Pete did. So you can already tell, obviously from your homework sheet, how big the distribution is going to be. So I want you to be thinking about what's going to happen to the standard deviation. Do you think it's going up? Do you think it's going down? Because remember, Pete's distribution only ranged from 2 to 6, and Erin's was even smaller, 2 to 5. So their standard deviations were not that great. But now, you should be wondering, why do we have this huge probability distribution now if I'm looking at the difference between the two? So that's what this video is kind of here for. So I want to help you fill in the top values. That's going to be every possible difference between Pete and Erin. So like I mentioned, what if Pete only has 2 people, but Erin's over there with 5 people? 2 minus 5, we get negative 3. 2 minus 4, negative 2. 2 minus 1, 2 minus 3, negative 1. 2 minus 2, 0. If we kind of went into Pete having more people, maybe this is 6 minus 5 or 5 minus 4. Lots of different possibilities there. But I want to figure out all of these possibilities with you in this video so we can kind of figure out ultimately what happens to the mean and really more importantly what happened to the standard deviation between Pete and Erin. Okay, so in lieu of the snow day today, or the 2-hour delay, I made a snow-related joke. A little twisted, but moving on, that's fine. Okay. So, if you want to try it yourself, pause the video, don't look at this. But I feel like we pretty much got the gist. So let's just pretend that this represents Pete, this represents Erin. So 2 minus 5, we get negative 3. 2 minus 4, we get negative 2. 3 minus 5, negative 2. All the way over here is where Pete has more people. So 6 minus 2 is the only way we can have a difference of 4. A couple ways we could have a difference of 3. So it kind of took me a while to get all of these. And more importantly, I want to figure out the probability that they are going to end up with negative 3. So the probability that Pete does better than Erin by 3 passengers. Or the probability that, Erin does better than Pete. Erin does better than Pete by 2 passengers. Erin does better than Pete by 1 passenger. So I had to refer back to my original distributions, Pete and Erin. So I found the likelihood that Pete has 2 people. I found the likelihood that Erin has 2 people. And I multiplied them together. Went ahead and I did the same for negative 2. So if you are bored tonight, go ahead and try all of the rest because I actually want to finish this distribution for once. We have kind of been lazy and we've been skipping over that part. Okay, knowing that most of you probably are not super bored, I actually sat here and wrote them all out for you, so you're welcome. And I wanted you to be able to have those probabilities to type into your calculators. So if you have your calculator, grab it now. So I went ahead and I multiplied and I added and I multiplied and I added and I multiplied and I added. And I had to double check and make sure that, let me move this out of the way. I had to make sure that the total probabilities added up to 1. I was very relieved when they did, so I didn't make any mistakes. So it's a high chance that there's no difference between the two because there's so many possible ways for them to have the same amount of people. So this being the largest, and then kind of right around here, there's also a high chance that Pete only beats Erin by 1 passenger, or even that Erin beats Pete by 1 passenger. So you can kind of see how these numbers end up making sense. So pause the video. All I need you to do is fill in these numbers. I don't need you to fill in all of what I have in green. What I want you to do with those numbers is use your calculator to input them into L1 and L2, answer 1, 2, and 3, start to be thinking about how we ended up with that mean, and then the standard deviation should seem familiar to you. So I want you to think about how we ended up with that standard deviation as well. So again, type these numbers into L1, type these numbers into L2, use one variable statistics to help you get the new mean, so of the difference, and the new standard deviation.